Okay, we're going to talk about the non-metals today. What I want you to understand is that the non-metals are over on the right-hand side, opposite to the metals that are on the left-hand side of the periodic table. What I'd like you to do is understand that the metals or the elements that are in between the metals and the non-metals we call metalloids. And those have characteristics of both metals and non-metals because the suffix oid means like, so metal-like. The non-metals are these elements on the right-hand side, and they have properties that are the opposite of the metals. The properties of non-metals are that they are brittle, and that would be opposite to malleable. So the metals are malleable, the non-metals are M-A-L-L-E-A-B-L-E, sorry. They are dull, opposite to lustrous or shiny or reflective of light. So they don't have luster, they are dull. They are insulators, which is the opposite of conductive because metals are conductive. They conduct heat and electricity, and non-metals insulate against them. And the last one is that they are non-ductile. So they can't be stretched into wires because of their brittle properties. Okay. Something else that we talked about in this part of the chapter was that the noble gases are the gases in group 18. They're gas at room temperature. What we need to know about the noble gases is that they are non-reactive because they have 8 electrons in their valence shell. So they're happy, they like their valence shell full. So the noble gases are non-reactive because their valence shells are full. The next group that we needed to understand are the halogens. Those are in group 17, and they're very reactive. And if you look that they're in group 7A, which means that they have 7 valence shell electrons. So they want that one electron. So they have 4, 5, 6, 7, and there's one missing, and they're really interested in filling that extra seat in their shell. So these guys are very reactive because they're always seeking out that 8th electron, and they will actually usually meet up with guys who have 1 electron to give away, and don't forget those are the guys in group 1A. So they'll typically get together with these guys, and when they do get together, they form what we call a salt. And we'll talk a little bit more about salts in the next chapter, but a salt is typically something that forms ions when put into a solution. So if you have this chlorine and he mixes with sodium, you get sodium chloride, which is NaCl, and that's just your common table salt. And some of you guys might have seen potassium iodide, lithium fluoride. Those are all salts, and it's because these guys in the halogen group, I'll write that down, H-A-L-O-G-E-N, halogen, these guys want to combine with these guys because they want that extra seat in their valence shell filled up.